Let's now simplify this trigonometric expression, that is cosecant phi over cosecant phi minus 1 plus cosecant phi over cosecant phi plus 1. So first we have to identify the least common denominator. If you look at the first expression, we have cosecant phi minus 1 is the denominator, and the next denominator is cosecant phi plus 1. So basically the least common denominator is the product of these two expressions. So I'm going to put that as least common denominator. Like this, I write down cosecant phi minus 1 times of cosecant phi plus 1. And then I can do the cross multiplication like this. That is, this term has to be multiplied with this term, and this term I can multiply with this term. So I can put that in the numerator. So therefore, this becomes a cosecant phi times of cosecant phi plus 1. And then we have the plus, and this term is cosecant phi multiplied with the cosecant phi minus 1. So we will have like this. So let's simplify both the numerator as well as the denominator expression. So I'm going to distribute this cosecant phi with these two terms in the bracket, and similarly this cosecant phi I have to distribute this with the two terms inside the bracket. So when I do that, I'll be getting cosecant phi times of cosecant phi is cosecant squared phi, and plus 1 times of cosecant phi is cosecant phi. And now we multiply this, that is cosecant phi times of cosecant phi is cosecant squared phi, and minus 1 times of cosecant phi is negative cosecant phi, and over. Now if we look at the denominator, we have a difference of squares. We can apply the difference of squares formula because we have a minus b times of a plus b, where a is cosecant phi and b is 1. So we can write down this as a squared minus b squared, where a is cosecant phi. So therefore in the denominator we will have cosecant squared phi minus of b is 1. So b squared is 1 squared, which is 1. So I write down this as 1. Now let's look at the numerator. We see that this cosecant phi and this negative cosecant phi, we can cancel them, and basically these two are like terms, that is cosecant squared phi plus cosecant squared phi. These two are like terms. When we add them, we will get 2 times of cosecant squared phi. So I write down 2 times of cosecant squared phi over cosecant squared minus 1. In fact, we can simplify this using a trigonometric expression. That is, we know that 1 plus cotangent square theta, this equals cosecant square theta. So this is a Pythagorean identity. I subtract 1 from both sides, then I will have cotangent square theta equals cosecant square theta minus 1. So we can clearly see that cosecant square theta is identical to cotangent square theta. And this means we can write down this cosecant squared phi minus 1 as cotangent squared phi. Now let's simplify this by rewriting this cosecant squared phi as well as the cotangent squared phi in terms of sine and uh, cos. So we know that cosecant theta equals 1 over sine theta. So therefore, when we square both sides, so this becomes cosecant square theta will be equivalent to 1 over sine square theta. So now I'm going to replace this cosecant squared phi as 1 over sine squared phi. So this becomes 2 times of 1 over sine squared phi, and divided by, in the denominator we have cotangent squared phi. We know the trigonometric identity cotangent theta. This is basically equivalent to cos theta over sine theta. So when we square this both sides, we will get cotangent square theta equals cos squared theta over sine squared theta. So therefore this cotangent squared phi, we can write down that as cos squared phi over sine squared phi. Now we have to just simplify this numerator and denominator. So first I put this 2, and then in the numerator we have this fraction, that is 1 over sine squared phi, and then we have to multiply with the reciprocal of the denominator expression. The reciprocal of this denominator expression is sine squared phi over cos squared phi. We can see that we cancel this sine squared phi with this sine squared phi, and finally we get 2 over, or 2 times of 1 over cos squared phi. And we know that 1 over cos theta, this equals secant theta. This is one of the reciprocal identity. So when we square this up, you will get 1 over cos theta, that is 1 over cos squared theta equals secant squared theta. So therefore this expression can be replaced as secant squared phi. So finally this becomes 2 times of secant squared phi. And this is the simplified form of the given trigonometric expression.